monomials, first thing we've got here, it says 8k to the third times 8k to the third y, excuse me, I forgot a y there, 8k to the third y times 9k y to the third. Now, there were some of these multiplying questions that were in that assignment that y'all worked on yesterday, so y'all already remembered how to do it pretty good, so it won't take too much effort today. First thing we would do on something like this, we've already gone over all of our power rules. I'm going to multiply my coefficient since this is a multiplication problem. 8 times 9 would get me a 72 on that. Then when I multiply variables, we went over this last week, we add powers. So in those k's, I've got a k cubed and a k to the first. So 3 plus 1, give me a k to the fourth. And then on my y's, I've got a y to the first and a y cubed. So again, 1 plus 3 would give me a 4. And that'd be it. Easy schmeezy.
Simple.
Okay, that would be, even though those are big, those are just monomials because there's not a plus or minus sign in between any of those terms. That whole thing, 8k cubed y, is one term. So that's a monomial times a monomial, what you just did on that. Okay, now here I've got a monomial, negative 2r times a binomial, 9r minus 5. So when we have a monomial times a binomial, it's distributive property. So we're going to take the monomial and distribute it to both pieces of the binomial. So negative 2r times 9r, do your coefficients, negative 2 times 9 is negative 18. And then your r and r, r squared is correct. On the negative 2r times negative 5, you can do your signs different ways. I go ahead and say a negative 2 times a negative 5 is a positive 10. And then I don't have anything to add my r to, so just the r stays there. That's a monomial times a binomial. Alright, let's look at a binomial times a binomial. I've got 2k minus 5m times 3k plus 2m. Alright, so I've got a binomial times a binomial. Now your options for this, you could take this 2k, distribute it to everything over here, take the negative 5m, distribute it to everything, and then combine like terms. That'll work. That's how some teachers do that. When I have a binomial times a binomial, I always do FOIL. So that's what I'm going to be looking at here. Do the first ones, and I'll go through that to remind you of the outer, the inner, and the last. First, the F means the first one in the first parentheses times the first one in the second parentheses. So 2k times 3k. 6k squared. Outer means the outer edges of the two binomials. So it's 2k times 2m. Now you can't add or subtract when they're not like terms, but you can multiply. So that 2k times 2m, 2 times 2 is 4. K times m is just k times m. Okay, and then the I, the inner, that's the middle two, which should be right there. Negative 5m times 3k. They get me negative 5 times 3 is negative 15, and m times k. I'm going to put them in the same order that I did there. So k times m. And then the last, the L, that means the last one in the first parentheses and the last one in the second parentheses. So negative 5m times 2m. Good is negative 10m squared. Now 95% of the time in FOIL, you're going to have like terms to combine in the middle, and we do on this one. 4km minus 15km. Negative 11km. That's it.
Forgot to square them.
Uh-oh. Alright, I'm going to give you a FOIL, another one to do, to try, and then I'm going to show you a new way you can do it if you like. If I had 5a minus 2b times 3a plus b. Alright, go ahead and multiply those. And then I'm going to show you a different way in case you like a different way better.
If it's like a 1 AB, is it just AB or is it 1 AB?
Either one's right. I just write AP, but either one's right.
It's gonna be hard to beat that way. I love that way. It's easy.
That's the way I do it too. Alright, what'd y'all get?
15A squared minus AB minus 2B squared.
Alright, anybody have problems getting that? Pretty simple. Now, I am the FOIL fan, so I'm going to do that FOIL every time. But there are other ways. I talked to you about distributing the 5A to everything over here, then distributing the negative 2B to everything over here. Another way to do that would be to organize it vertically. Stack them like that. So now what you would do, and this is the same thing as distributing, you've got this B here. You would distribute a B to both of those on top of it. So B times negative 2B is negative 2B squared, and B times 5A is 5AB. Okay, then when you're done with that, we distributed that to everything. Remember when you were a little taught, when you moved to the next term, what did you have to do here? Put a 0. Good job. So now I got to take this 3A to both of those. So 3A times negative 2B be negative 6AB. 3A times 5A, 15A squared. Then you combine your like terms, which ours are stacked up because we put that 0 scout, remember? 15A squared minus AB minus 2B squared. So that's just a third way of doing it. I still like FOIL better, but you do it any way you like. That way that we just did, you can do that if it's like a trinomial times a binomial when you can't FOIL. So that can help you on other types of problems. Okay? Alright.
Wait, when can you not FOIL?
If they're both not binomials. If one of them's got 3 terms or 4 terms, which is what we're fixing to do.
Okay. See what I do.
Alright, this one here says 2A minus 5. So we got a binomial there times 5A cubed minus 6A squared plus 2A minus 3. So this one's got 4 terms. So we're multiplying. Can't FOIL because they're not both binomials. So here's our options, and I'll do them both if we need to. It's basically distributive property either way you want to do it. The way I'm going to do it first is I'm going to take this 2A, I'm going to distribute it to all 4 of those. Then I'm going to take the negative 5 and distribute it to all 4 of those, and then I'm going to combine like terms. Okay, I can do it that way, leaving it written out long, that's called horizontally, and do it that way. Or I could stack them like I just did on the last one, that other new way I showed you, and do it vertically. It's the same thing. So I'm just going to leave it like this right now and take the 2A to every piece over there. So 2A times 5A cubed is what? 10A to the 4th. Very good. 2A times negative 6A squared is what? Negative 12A cubed. Good job. 2A times 2A is what? 4A squared. Good. And then 2A times negative 3. Good job. Now, it's up to you how you write this because we've done the 2A to everything. Now I got to take the negative 5 to everything. You can keep putting, when you distribute the negative 5, you can keep writing them out here to the right if you want to. That's fine. what I usually do when I write it is I'm going to stack like terms up. So I've got my like terms already by each other, and you'll see what I mean as I start going. I'm taking the -5 to the 5a cubed. What does that get me? And so I'm going to write that underneath the other a cubed. Now you don't have to do that. That's just my preference.
That's right. You always add like terms, right?
Mm-hmm. And then I got -5 times -6a squared. Positive, right? Positive 30a squared. And I got -5 times 2a. -10a. And then I got -5 times -3. Positive 15. And there wasn't a like term for it to go underneath. So see, it just stuck out there. Alright, now what Austin was talking about here when I combine these like terms, just adding 10a to the 4th plus nothing is 10a to the 4th. -12a cubed plus -25a cubed. -37a cubed. 4a squared plus 30a squared. 34a squared. -6a and -10a. -16a and then plus 15. That's your answer.
Whoa, did I just do it? Oh, yeah, I did.
Good. All right, does anybody want to do it vertical? Do you want me to stack them and do it that way? No? It's the same thing, you just distribute it.
No, I'm weird.
Well, we already knew that, Louise.
I didn't have anybody to call me yesterday.
Honesty is the key to success.
No, I want you guys to watch it.
Alright, this is back to binomials, but this is a special case here. M plus 5 times M minus 5. What's going to happen like that when it's the same terms, but one of them's a plus and one of them's a minus? Every single time your middle terms are going to cancel out. I'm going to go through the FOIL and show you, but you'll see that it's a difference of squares is what we call that when we factor it. And y'all do realize that when we're multiplying these, it's just the opposite of factoring, right? Okay, with that?
Yeah.
Alright, so first gets me an M squared. Outer gets me a -5M. Inner gets me a positive 5M. And then last gets me a -25.
Middles cancel out.
-5M and 5M's nothing, so you just got M squared minus 25. Every time the terms are the same, but just one of them's a plus and one of them's a minus, the middle terms are going to cancel out. Now, if you forget that, are you gonna get it wrong? No, you can still do the FOIL and get it. It's fine. It's just little shortcuts like that that you can pick up on.
You just multiply 5 times 25. Alright, that's cool.
Okay, so for the ACT Saturday weekend, I felt like the math was a lot easier.
Good.
Heck no! I thought that was the hardest ACT I've
No,
ever.
the science was
hard, but I
hard.
thought the
I
math
thought
was a lot
the
easier.
The
heck.
science was
The
hard.
science was easy.
I had to guess on 3 whole columns.
That math, I was
Me
like,
too.
what do I do? Like the whole time.
Yeah, the math was hard.
But there was a matrix one, and I
Yeah,
know
that
that
was. But at first, I typed in like the wrong I typed in like 3 by 2.
First, I forgot my calculator in my car and had to sprint out there and get it.
My calculator, I don't know why, because I'm using yours, and then I found mine at home, and like my calculator wouldn't let me do a matrix, and I was like,
Ooh, what? I think I'm
so I was like,
Alright, this one says t plus 9 squared. Now, yesterday, the Algebra 2 assignment that they got left was multiplying, so they were doing this yesterday on their assignment. And I was looking through them this morning, and I had a lot of people for this just write t squared plus 81. That's not right. They were just taking that squared and distributing it to each term. They forgot that when you square a binomial, that means you got to write the binomial twice. Okay, so this t plus 9 squared is the same as t plus 9 times t plus 9. Now there's also a little shortcut on this one that I'm going to show you. This is a sum of squares. I'll show you the little shortcut. Nothing can cancel out on this, but there is a little shortcut for you. When we do our FOIL, t times t is t squared. Outer, 9 times t is 9t. You get the same thing on the inner. That's where the shortcut's going to come from in just a second. And then last is 81. So when you combine those middle terms, 9t and 9t is 18t. So that's your final answer. So the shortcut on that, when it's the sum of squares like this, when it's the same thing twice with a plus sign, your middle term is just double. 9 times 2 is 18. So I don't usually remember that one as often as I do the canceling out one, but that is a little shortcut for you.
It wouldn't let me do fractions either on my calculator. I was like, what is wrong with this stupid calculator? So I like put everything in parentheses and use the divide button like,
Yeah.
18t. Crap. Ever tried the other pencil sharpener?
It's over there on that bookshelf.
I normally press next.
Alright, this next problem is probably the most difficult looking one.
Is it the most difficult or is it just difficult?
That's not too bad. I got 3p minus 2 plus 5q and then times the same thing.
I had one of these on here. I didn't know what I was doing. I had one of these on mine.
Alright, so that is the same thing twice, right? So I could look at this and say, well, I've got to take 3p minus 2 twice, and I got to take 5q twice, right? Easily, you scared me. Okay, so how would I attack this 3p minus 2 twice? Right, twice and pull it. Good job. So I got 3p minus 2 times 3p minus 2. So that gets me 9p squared minus 6p minus 6p plus 4. Combine those like terms there now. That gets you 9p squared minus 12p plus 4.
And then you right.
Okay,
that
now,
twice.
good. We have this 5q squared. Okay, there's
25q.
good. Square both pieces. 5 squared is 25, and q squared is q squared. That's it.
Would you not put it at the beginning?
You could. Yeah, you could put what Austin said. I could put 25q squared plus 9p squared. That would be the same.
Is that how the answer would be? They probably put it up in the front.
Well, if it had had a higher p, they would have. But a lot of times you'll have, if you got different variables, they'll split them like that. They'll put one on the front and one on the back.
I don't like using. I think that the reason why I just freaked out is because all those brackets, and I was like, I don't know. And then I was like, there's a bracket on the calculator, but it just, I just guessed. Yeah, I didn't get it.
Did you put C?
Yeah. I put that on everything. I remember who I was talking to, so like, I literally put C for like the last 3 columns on my own. Yeah, that's like me.
Mine was on the
That's why I
signs
took
though.
that score. Because I don't have enough time.
Alright, what about if we had something like this? X plus 2 to the 4th. Shh. Okay, we got to write it 4 times.
I'd write it twice, boil it, and write it twice again.
Uh-huh.
That's what I'd do.
Uh-huh. Alright, there's my 4 times. Now from there, what Austin has said, when we FOIL, I'm gonna draw me a line there to FOIL 2, and I'm gonna get the same answer when I FOIL these two, aren't I?
Yeah.
So that's gonna, let's go ahead and see what we would get on our FOIL. X squared 2x, I'm skipping a step, 2x on my outer and 2x on my inner is 4x. And then my last is 4. So I get that on the left and the right. Okay, so your options now, you could stack those and do it vertical like I showed you, or leave it out horizontal like that. You got to take the first term, x squared, distribute it to all three. The second term, 4x, distribute it to all three. The last term, 4, distribute it to all three. Okay, you ready?
Ready.
X squared times x squared, x to the 4th, x squared times 4x, 4x cubed, and x squared times 4, 4x squared. Come on, that's not rocket science. Okay, we're done with that first x squared. Now I'm taking the 4x. 4x times x squared, 4x cubed, 4x times 4x, 16 is what you said, x squared, 4x times 4, 16x. Okay, I'm done with the x squared, I'm done with the 4x, now I've got the 4 left. You ready? 4 times x squared, 4 times 4x, and 4 times 4. Alright, so I've got all my like terms lined up. So I'll bring down that x to the 4th. 4x cubed and 4x cubed is 8x cubed. 4 16 is 20 and 4 more is 24. 32
16.
and 16.
Good.
Now, Algebra 2 did this one day last week, and y'all did it last year. I'm not going to get into it this year with you, but remember when we used Pascal's triangle and expanded those?
Yeah.
You could have done that there.
And we made that poster.
I took class for a week. Because I'm supposed to still be in it. I'll still be playing.
This was the 4th power, so we would have went, was it the 4th power? Yeah. So we'd have went to the 4th row, that's row 0, 1, 2, 3, 4. So those would have been our starting coefficients. Remember that? No, we're not gonna get into that this year, but that would have. Alright, last thing on our bullet up there is multiplying functions. So let's multiply some functions. Do you think that was a birthday cake?
No, it looks like one.
I didn't think
Snap.
Shelby. Snap.
I had nothing to
Give
say.
it back to you.
What?
Well, hey. Oh, I didn't do.
Alright, we are going, we're going to do 2 things of this. We're going to find f times g of x, and then we're going to find f times g of 2. Alright, f times g of x, that's nothing that you haven't done already today, it's just writing it a different way. F times g, you're just multiplying your 2 functions. F, 3x plus 1, times g, 2x minus 5. So that's stuff that we've already done today. They just write it different to try to confuse you. So that's a FOIL problem there. Okay, so first we get 6x squared. Good. Outer we get
Negative 15.
good. Negative 15x. Inner plus 2x. And then last
Negative
minus 5. Okay, you got some like terms in there.
6x squared minus 13.
Very good. So that would be our f times g answer. Okay, so that was the first thing I asked you for. Okay, pretty simple. Now the other thing I asked you for was f times g of 2, so you've got options on how to do that. Let's go back and look at the other problem I asked you for. You could take a 2, put it in the f function and get an answer. Take a 2, put it in the g function and get an answer, and then multiply those two, because that's what fg means. Or since you already got f times g here, you can just put a 2 in there. That's what I would do. So I'm going to have 6 times 2 squared minus 13 times 2
Oh.
minus 5. So 2 squared, only the squared's only on the 2. 2 squared's 4. 4 times 6 is 24. 13 times 2 is 26. That's negative 2 minus 5, negative 7.
115.
I bet you squared 12.
I did.
On that squared's only on the 2, so just square the 2.
Oh. Okay, so then it ended up being what, 6 times 4?
Yep.
Okay. 6, 12, 18, 24.
Yep, I do.
Well,
Every
you
day.
heard wrong.
Every day.
Okay, what told me that you guys.
24 minus 26 minus 5. Negative.
Who are you talking to?
Hey.
No, I don't know.
Connor?
I don't know.
I don't remember that, but
I'm a fan.
Alright, we've got still dividing is left to talk about, so that's what we'll do tomorrow is some dividing. We can divide with synthetic division and long division. Those are both reviews from Algebra 2, so we'll look at that. Then we'll have to figure out when, I'll have to look at it and figure out when the best day for our test is going to be. So that'll be on the horizon.
I hate long division. What does that mean? I've never been able to do it.
You're going to
you
this
know,
time.
I forgot.
I never learned to
I've
have to
forgotten
do
how to even.
I forgot.
I never even learned.
Because I was sitting in here.
You've never known how to do it either? Me either. I just can't catch on to it. I don't know.